Okay, so we've got Google Earth here. And what I wanted to show you, let me put this other thing down too, right? What I wanted to show you was what happens, like when you look at the highest point of land in the Atlantic Ocean, right? Which is going to be, oh, you see, what do I have here? It's like you need to turn it a little bit. Okay, somewhere right around here, I would think. It's going to be the Portuguese Azores, right? And if I say, and you may have seen this before, right? Pico Island.
I've heard you speak of it before.
Pico Island, right? This is the highest point of land in the Atlantic, okay? This is the center of what you call the Atlantic Bulge. Okay, and these are like the Portuguese Azores. Okay, so if I keep the mouse cursor centered on Pico Island here, then I've seen graphic reproductions of the breakup of the supercontinent Pangaea, and it starts at Pico Island, right? The Portuguese Azores. I mean, this would be this would be the point at which the Tethys Sea came to a point, right? This would be the point at which Pangaea broke up from. Okay, so so we've got the Earth centered on Pico Island here. Now, what happens if I just say, okay, Pico Island, center here, and then turn the whole thing around 180 degrees. You see what I'm saying? All you've got here is water. This is what I call the Pacific Void, okay? Pico Island would have been the sub-Saturn point. That would have been the point. You know, why would that be the highest point of land that there was, right, in the Atlantic? Well, that's because that was the sub-Saturn point, right? That was the point at which all of the electromagnetic and gravitational pull came to a head, right? If you turn the planet around from that point, then what you get is the place where those first humans coming from Ganymede would have splashed down, like right in the middle, smack dab of the Pacific Ocean. Now there's islands there, and they could have, you know, left to their own devices, they were just all going to drown or die of exposure or something, right? I mean, they weren't going to have a happy time of it. What I believe happened is that you have these symbiotic relationships in those days, right? You had, like, humans were aquatic mammals, right? You have the other aquatic mammals, you know, particularly the whales and the dolphins and the sea creatures that had splashed down with the humans from Ganymede just set out an SOS. So you got humans here in the middle of the freaking water, right? They're not going to survive. We need some help, right? We need somebody that can carry, you know, swim and carry some kind of a load, right? And we need to take some of these people to either to some island or to Australia, some kind of a place where we've got dry land. We've got some kind of a chance to survive. That's what I believe happened. Okay. If you come back just a little bit, you've got Australia here, and you know this would have been the nearest point, the nearest large point of dry land, you know, that you had in the Pacific Void. You know, after these people splashed down. Okay. The Ganymede hypothesis is compatible with an out of Australia theory. Okay, it's like you've got one particularly interesting Facebook group, which is called, you know, the Out of Australia Theory. I forget the exact title of the thing, right? But you got Stephen and Evan Strong, you know, who you might have heard of, and, you know, that's their Facebook group, got about 20,000 or 30,000 members. Okay, so you got a little bit of an audience there. Um, anyway, that's the thing about, Pico Island and where those first humans would have splashed down. This is the point, the center here. Let me.
See,
I'm sorry.
I didn't know that.
Okay, well, I mean, I've seen one or two things like I've watched like 3 or 4 of your videos here lately, from within the last year. One of them said something about some other place being the sub-Saturn point, and I don't believe that. I believe Pico Island had to have been the sub-Saturn point. Like I said,
that was your compatriot, Troy McLaughlin, who said
Yeah,
it was Atlantic Sea anomaly or something.
Troy got totally freaked by me wanting to talk about the Thunderbolts group having got this whole thing wrong, with claiming that Velikovsky was wrong, and that Venus had arisen with Saturn and not Jupiter. Okay. And that I know I'm 100% certain on that one. I'm right about that. That's like, when you've got like Jupiter and Venus having, the exact same axis tilted within less than half a degree, I don't believe in extreme coincidences. Okay. There's a reason for that. And it's like when you go back to the Velikovsky affair and you get these arguments that were going back and forth in the 1960s with Carl Sagan, they were all talking about surface temperatures. They should have been talking about axis tilts. And what I believe to be the case is that like the axis tilt of Venus became known somewhere towards the mid-60s. So, Sagan was probably working like it didn't occur to him. It doesn't seem to have occurred to anybody. That's the biggest key to the whole thing is axis tilts.
I believe you're right. Yeah. You never hear cosmos.
Axis tilts are hard evidence, okay? It's like, that absolutely has to trump any kind of a case that you could make working entirely from mythology, ancient literature. Okay. We're talking, the axis tilts of the relative eye sizes are hard evidence. And those are the two main pieces of evidence that the Ganymede hypothesis is constructed from. Okay, so let me get out of that. So it's like that's the case for the Ganymede hypothesis or for Pico Island, right? Like I say, the clincher for Pico Island is this video that I've seen, which I don't have a link for right now. I'll try to come up with one, but it's like it shows Pangaea breaking away. And the point that it breaks away from is Pico Island, the Portuguese Azores. Now, I had a couple of other things sitting here.
Oh, that was the North Pole?
I'm sorry?
Pico Island was the North Pole?
Yeah, Pico Island was the sub-Saturn point.
Okay.
That was the highest point. It still is. It still is called the center of the Atlantic bulge. Okay, it's what do I have here? I've got like the Mozilla browser, right? Firefox. I cannot get my Vivaldi browser to work properly on this laptop. I mean, this is a laptop that I'm extremely happy with. It's a refurbed Hewlett-Packard commercial grade.
Mm-hmm.
ZBook laptop, right, 17-inch screen, 32 gigabytes main memory. I mean, that's pretty slick. At any rate, I had 2 of the pages on my little Steemit blog. Steemit.com is it's mostly about cryptocurrencies, right? But it gets used for all kinds of other things. And I use it as a blog site, right? And I've got like, I don't know, several hundred blog posts on Steemit over a period of 10 years or whatever. And it's sort of a mix of political topics and renegade science, right? You'd have to take choose what's interesting to you, right? But on Steemit.com, this is going to look like www.steemit.com/@Gunga Snake, okay? Gunga snake would be like a yellow and black whifferdille, like Gungasnake, one word.
Let's get into it.
Okay, that's my little blog site on Steemit. At any rate, what we're looking at here is there's two of these posts. Okay, one is called Ganymede Hypothesis, Logic and Images. The other is called Deep Prehistoric Climate Optimum and Golden Age, and this is like the thing that I think is interesting, Greg. It's like I believe that I've come up. I mean, I don't have all the answers just yet, but I believe that what I have at this point is a fairly complete picture of the prehistory of our solar system. Okay, and this is called the. Let me just go over some of this. I'm not going to read through it word for word, right? But so human origins, solar system origins have to be studied together. There's no making sense of one or the other separately. Okay. Most major piece of evidence, planetary axis tilts, relative eye sizes of the creatures living on the planets in question, or the bodies in question, right?
Mm-hmm.
Older wiki pages and likely most astronomy books give the tilts of Jupiter and Venus as 3.13 for Jupiter and 177.3 for Venus, right? That doesn't look very much alike. Most people would just, would just glance at that and move on, right? But the hell of it is that you have to look at that as angle distance between that and a perpendicular to the plane of the system, right? And if you look at it that way, then Venus and Jupiter have the exact same axis tilt to within slightly less than half of a degree. Okay. That's what this says, half a degree. Newer wiki pages give the tilt of Venus as 2.64 degrees. So you're looking at 3.13 and 2.64. I mean, the difference is like about 0.49 of a degree or 0.48 or something, right? In other words, I don't believe in extreme coincidence. That's not a coincidence. That absolutely nails the case for Velikovsky. That says that, like, Velikovsky went for like a number of pages, and he.
Oh, you're back. Okay, cool. Sorry.
Okay. You're talking to Andy?
Yeah. He left for a minute.
Okay. That's fine.
That's right. Okay.
This brings up the subject of Immanuel Velikovsky claimed that Venus mounted material had been ejected from Jupiter as a means of relieving electrical stress. The thing about axis tilts likely would not shock or surprise Dr. Velikovsky, right? Everybody else totally snapped by it. Nobody should believe in extreme coincidences, and there's no way to start with either standard theories or David Talbot's version of a Saturn theory and see Jupiter and Venus having the same tilt as anything other than extreme coincidence, right? So that says that the Thunderbolts group is completely wrong about that part of it. It's like they need to get together and rethink. Okay, now like I said,
you're talking about Venus coming from Jupiter. You think? Yeah. Right. I agree.
He said he was 100% certain about that, and he said he'd put a great deal of time and effort into it. This is the very most careful scholar that I've ever heard of. Okay.
Yes.
He goes on for like 10 or 15 pages in Worlds in Collision about the reasons for identifying the source of Venus as being Jupiter, not Saturn. Okay. Velikovsky also predicted the conditions to be found on Venus, particularly the extreme surface temperature, and that was in 1950, when science books were telling us that conditions on Venus are almost certainly similar to those on Earth. His sister planets, similar history, right? Very close to each other in the solar system. But the story about axis tilt, at any rate, so Velikovsky nailed this thing, contrary to all accepted wisdom at the time. And you would have thought that in a rational world, there should have been a line of scientists a mile long waiting at Velikovsky's door to apologize. Once they found out what the surface temperatures and conditions were on Venus in the mid-60s. Yeah, well, no, it didn't happen, right? It's like they didn't all line up to apologize. What you had was this Carl Sagan,
Yeah.
Fabricated the super greenhouse theory, which is still the standard theory for explaining the surface temperature of Venus, even though it's garbage, right?
Anti-theory theory.
It's an anti-theory theory. It's a theory deliberately cobbled together to prevent Immanuel Velikovsky from receiving credit for this astonishing prediction of his.
Right.
Okay, we've had descender probes. Both the Americans and the Russians have had descender probes go to the surface of Venus, and they both said that there was absolutely no light to be found in the middle cloud layers, and then you had light getting brighter as you got towards the surface in such a way that a rational person has to believe that the light at the surface is locally generated, right? That's coming from electrical plasma physics phenomena and heat, right?
Yeah.
Chemical reactions. Okay. So there's absolutely no way. Sagan's theory depends on some molecule of sunlight getting through all that stuff and generating heat on the surface, and then the heat cannot re-radiate as infrared because of the cloud layer, right? Well, that's garbage. Like I say, it's like any modicum of sunlight that ever got to the surface of Venus would have to be like a drop in the ocean compared to the local, to the 99.9999% of that light at the surface, which is locally generated. You see what I'm saying?
Mm-hmm.
Okay. The story about axis tilts gets better starting from all of that. Uranus and Pluto, which are two of the three bodies in the outer reaches of our system, have oddball tilts. Best idea seems to be just to ignore them. They likely have some kind of separate little stories of their own.
Yeah.
But the other major bodies divide into two distinct groups. You've got the Sun, Jupiter, Venus, and Mercury all have axis tilts less than 10 degrees, which is more or less what you would expect to find, right? But Saturn, Neptune, Mars, and Earth have tilts ranging from around 23 to around 28 degrees, roughly 26 degrees, right? That suggests that those bodies had been a separate system early on, been captured as a group probably recently. The idea is this: those bodies still in a linear alignment left over from the formation of the system as a Hervig Haro string flew into the plane of the Sun-Jupiter system at a roughly 26-degree angle, and as the individual bodies were captured and began to orbit as they do now, ordinary gyroscopic force caused them to retain that roughly 26-degree angle of approach in the form of axis tilts, right? That's the reason for it.
Okay.
Now, we tend to think, and this is something that I've noticed in a couple of your videos, and I see this even in artwork coming from Troy McLaughlin, right? Mm-hmm. It's the hardest thing in the world to get old habits of thought out of your head. Okay, yeah. There's nothing hard in that.
Yeah.
If you're thinking the same way about something, like for 50 or 60 or 80 years, it's damned hard to change the way that you look at it, right? It's like, I went for 55 years without ever owning a cell phone, right? So that I'm always getting into my car and starting to go somewhere, and then I'm like, oh, geez, I don't have the cell phone with me, right? So, I'm not,
you too? Yeah.
I was hoping I could die of old age without ever touching a cell phone. I didn't, somewhere around 2002, I was getting into too much trouble because, you couldn't find pay phones anymore. You see, when I was a child, you were never more than 30 feet away from a pay phone, even in the forest.
I remember those days. Yep.
Remember that? Today, like Superman would go crazy. I have no place to change clothes.
No.
Right?
Yeah, you don't see pay phones anymore.
No, they don't exist. Don't exist, okay? So at any rate, here we've got a situation. It's the same kind of thing, right? We tend to think of solar systems as orbiting systems, okay, governed by gravity. Since our own system behaves like that, but like I say, I think I've seen, what's the term you use for synchronous orbits? Maybe explaining some of these alignments, right?
Mm-hmm. I can't think of it offhand.
It could be that 60 or 100,000 years ago, you had some things in orbit around some other things, right? But it's like, I wouldn't bet it that way. Okay, I mean, I don't have a I don't have an explanation for all of Saturn's moons, right? I don't have an explanation for Titan, where that was during all these ages that we talk about, right? But
Yeah.
the main bodies of the Saturnian system, like Saturn, Neptune, Mars, and Earth, you know, the bodies with the roughly 26-degree axis tilt, that was, I mean, no part of that was orbiting any other part of that, right? That was not an orbiting system. That was a linear alignment, you know, left over from the electromagnetic alignment of the original Herbig-Haro system.
Now, do you think the Earth came from Saturn?
Yes.
So Titan would be closer to a sister than Venus.
Correct.
Yeah.
Yeah, I would bet it that way.
But
Unless Titan was.
Yeah. I always wonder why did Titan get any water? There's no water.
I'm sorry?
No water in Titan. How the hell did that happen?
I don't know. I don't have all the answers, Greg. I've got some of them, and some of the answers. Some of the questions I do have answers to are very big ones. Okay. Mm-hmm. Here's what I'm saying. Look, we tend to think of solar systems as orbital systems. Nonetheless, late antediluvian artwork clearly shows a linear alignment of planets governed by electromagnetic forces and not gravity.
Correct.
What you've got here, you've got on the right-hand side of this little picture, you've got the Shamash glyph, which is Babylonian, right?
Yeah.
And you've got like Saturn and then Venus and then, or I'm sorry, Saturn and Neptune and Mars, right?
Yeah.
On the left, you've got like Saturn and then Neptune and then Mars. And this would get me, like I said, this frosts the Thunderbolts group and it frosts Troy McLaughlin. Troy, the happy little duo, right? Dynamic duo. That was like, Troy said he didn't want his name being associated with this claim that goes against the Thunderbolts group. You know, I'm sorry, people, but it's like, you know, the Thunderbolts group is wrong about that.
Oh, you know, that's just a disagreement. That's all that is.
Yeah, this blue body in this picture is
not to disagree.
Yeah, the blue body in this picture is assuming that this picture is the Saturnian system. Then the blue body is Neptune. It's not Venus. Okay.
But
now,
why would Mars be so big against Neptune then?
Closer.
I see.
Just a question of distances.
So
now the other
to the Earth. I get it. Okay.
The other possibility is that the Shen clasp is a picture of the post-diluvian alignment, which would be that's still hard to picture, right? Because
the reason why you're saying it's Neptune is because you're contending that if it was Venus, much more of Saturn would be showing.
No, I'm saying that Venus does not have this roughly 26-degree axis tilt that you'd have to have to have ever been part of that Saturnian alignment. Okay, look.
Yeah, okay.
Axis tilts, Greg, here's part of the thinking. Axis tilts do not seem to change much over time. Okay, you've got Earth and Mars that have gone through every bit as much grief as Venus ever went through, and they've still got that you know, the axis tilts do not seem to have ever changed very much. You know, they've still got that roughly 26-degree axis tilt. Right. If Venus had been part of the Saturnian alignment, it would still have that roughly 26. Its axis tilt would be somewhere between 23 and 28 degrees, right?
That's right.
Roughly 26.
I see.
Roughly 26 degrees, right? It wouldn't be the exact same as Jupiter's axis tilt,
which Venus is.
Yeah, Venus has the exact same axis tilt as Jupiter to within less than half a degree.
Right.
And you've got to get that. You've got to incorporate that into your thinking, right? Okay.
What do you think about it being upside down? Do you really think it's upside down?
There's a reason for that.
Why it was the way it was kicked after birth? Because it was born in a nova.
Yeah, it's like it's like gears. You have to think the way you would if you're looking at a gearbox in a car.
Right.
Right. It's like when gears mesh, the one turns the one way, the other turns the other way, right? It's like, what's the other gentleman's name from South Africa, right? And Thomas Morgan basically cleared that up. He said, you know, what you have to picture is like Venus being ejected from the equatorial region of Jupiter. And with that, he said, you're going to get this mass of material being turning the opposite way with the material of Jupiter itself. And as it breaks free, it's going to have this reverse spin.
You know, the clasp itself is at a 26-degree angle.
Yeah. Well, like I said, the older books give the axis tilt of Venus is like 177.3 degrees, right? Whatever,
Right.
and then
Yeah.
you know, but that's because of the way. It's because of the retrograde spin and because of the way it was formed. Okay, that would be showing a crescent of light. This picture that you're seeing here is what the artists were seeing. You know, particularly for the Shamash glyph or for Egyptian artwork, which looks like this, right? Where you're seeing.
So
And
then
this
Venus, just one more thing before we move on. So Venus was basically born from Jupiter that was not even a part of this alignment. How could it be?
That's correct.
Okay.
Venus was born from Jupiter. It was not born from Saturn. What you've got here is Saturn. This is late antediluvian. This is at a late stage of the Saturnian system approaching the Sun-Jupiter system. And you've got light coming from the Sun or from the Sun-Jupiter system. And then you've got like a crescent, which you're seeing. Okay, this is still, what I believe to be the case, that this is still the Saturnian system, not the post-diluvian alignment, right? And there's an easy way you could get balled up with this. It's like, you know, after the capture of the Saturnian system, right, for a period of time, you had the Earth and Mars got caught up in a Jupiter-Venus alignment, right? So that for a period of time after the flood, after the capture of the Saturnian system, you had what I call a post-diluvian alignment, you know, which has got like Jupiter and then Venus and then Mars and then Earth, right? And that, I believe, is what David Talbot and F. Cochran have been seeing all along. Okay, that's where the confusion comes in.
Yes.
You know, they've looked at all these images and they've come to the wrong conclusion. Any rate.
Well, you know, people within Thunderbolts disagree all the time, I'm sure. So it's no big deal. It's just a disagreement.
This is a big disagreement here, Greg. This is not one of mine.
I know.
This huge disagreement. This says they've gotten a major part of the theory wrong. Gravity is by 40 orders of magnitude the weakest force in nature. You've heard me say this before, asking gravity to form up a solar system from swirling dust, hold a spiral galaxy together is like asking the littlest kid in the school to do the powerlifting event. That's stupid. What actually creates systems are cosmic Birkeland currents created by plasma charge separation in space and electromagnetic pinches where the current pairs of such a thing cross each other. Those pinches do have the power to agglomerate the plasma of space into stars, right?
Yeah.
Says a little about currents here. Space is a plasma environment, not a vacuum. There are charge separations across enormous regions of space, and because of these charge separations, we see Birkeland currents arcing across huge regions. Those are twisted pairs of currents that look like RNA DNA strings, right? And that's what you're seeing here. And you get these pinch points where the pairs of currents cross each other, and those pinches are what creates the Herbig-Haro strings, right? Where those current pairs cross each other's electrical short circuiting. What are called Z pinches, they do have the power to agglomerate plasma into star, protostars, stars, right? Birkeland currents with stars or protostars showing at their pinch points are called Herbig-Haro objects is the official term. Herbig-Haro objects are not gaseous jets. As some sources claim, a gas jet would dissipate in seconds in the near vacuum of space, okay?
One thing comes to mind, with you saying it's a major disagreement. There are certain advocates within EU that have moved away from Saturn theory completely, and I don't agree with that.
Okay, well, let me run this thing about Herbig-Haro strings.
All right, yeah, go ahead. Go ahead. I just
there's
wanted
two things I would notice, because it's like most of the official speak websites that you go to any kind of an official source. Herbig-Haro strings are jets of material being emitted by stars or by galaxies, right?
Right.
Or by whatever stars. There are two problems with that. Number one says that like a jet of material would dissipate in the blink of an eye in the near vacuum of space. It wouldn't last long enough to get a look at. And number two, you wouldn't have these little circular nodules in a jet of gas material. Okay, you look at Herbig. Let me leave this for a moment and go to a little search that I've been doing. This gives you a slightly better look at it, right? You see what I'm saying? Look, this is like a, where my mouse cursor is, you can see round balls,
yes,
okay?
Indeed. Yes.
Nodules, okay? And if you zoom this just the littlest bit, and I almost have to have like light or something, one finger over. Okay, just zoomed that just a little bit. And you can see it's very clear. Do you see what I'm saying? These are round balls. A jet of material is not going to have round balls like that.
Yes.
Okay, those are stars or protostars forming up. And that's also the reason that in the universe generally, stars appear in groups, right? It's like a system like ours with only the one main sequence star is an anomaly. You with me? This is the thing I wanted to show you, like with Herbig-Haro string. They're not jet material. It's like these are.
So do you think? Yes. Do you think the ones in the middle there that are bright, those are stars, obviously?
Those are stars.
What about these bodies? Are they planets?
You've got an interesting question, Greg. Is it possible that you get planets? Is it possible that you get, you get stars and you get main sequence stars and dwarf stars? Okay, because our system originally had like the one main sequence star and 2 or 3 dwarf stars, right?
Yeah.
There are two things I'm going to mention about Herbig-Haro strings. Number one, they're not jets. It's like they're Birkeland currents with stars or protostars forming up where the current pairs cross each other. That's number one. Number two is that they're generally straight, okay?
How long are they? Are they light years long? How long are they?
It could vary, right? I mean, is
that like 3 yards?
I don't know the answer to that, Greg. I would say that a close approximation might be the distance between the 2 main sequence stars of Alpha Centauri and Proxima. Let me get back to where I was.
Okay. So Ted, that would be that Herbig-Haro would be within a Birkeland current, would it?
Yeah, okay, that would be formed by a Birkeland current. Now, this gets better. Well, let me get back to my little page here. Like I said, I've got these 2 pages that I'd like you to take a look at here. Our own system originally looked quite a lot like that, right? That is to say, the Saturnian group, the bodies that later acquired the roughly 26-degree axis tilts, on one side, and then a bunch of open space, followed by the Jovian group, particularly Ganymede, and then our present sun on the far side. The normal situation in our galaxy is for gas giant planets and dwarf stars aligned with the main sequence star, like our sun, to be up closer, much closer, to the main sequence star that Jupiter or Saturn are now, which is why you read about hot Jupiters, right, quote unquote. Because, so in other words, having like either dwarf stars or gas giant planets off in the distance like we have in our system is an aberration. The normal system in the Milky Way is for gas giant planets like Jupiter or Saturn to be up close to a main sequence star. Okay, which is why I read about hot Jupiters. Such an arrangement of our own system would, of course, turn Ganymede into a freshwater ocean world instead of the frozen wasteland it is now. Now, this picture that I have here is what I picture our own solar system to have looked like early on. Okay, and let me get the one thing. I've got like, okay, let me expand this a little bit. I didn't mean to do that, but that's not bad. Okay, so what you've got here is that you've got like, and you've probably got Titan and a few other things sitting around somehow or other. This picture doesn't show everything, but it's not a perfect picture, but I believe this is the general idea of what our system used to look like a long time ago, right? Saturn, Neptune, Mars, and Earth, right? Then you've got a bunch of open space, and then you've got Jupiter and the Galilean moons, right? Ganymede. This whole thing is on a line, right? Because these Herbig-Haro strings are linear. And then you've got Jupiter, and then you've got the sun, right? Now, you get into a funny kind of a thing. Troy had drawn a number of images which were included in that first book of ours, Cosmos and Collision, showing Ganymede as if we should believe that it was in an orbital system around Jupiter, right? Now, if you put Ganymede in orbit around Jupiter, in this picture, what you're going to get is, at some point, about half the time, Ganymede's going to be between Jupiter and the sun, and you're not going to want to be there, right? Let me... Okay, this is from the present version of Trey McLaughlin's impressions of Ganymede in past ages. Okay, go up just a little bit higher. Egyptian crown design, no. This might be from Cosmos and Collision, I don't know, but it's like basically, this picture is almost believable, but then what you get, Sun-Jupiter system some tens of thousands of years ago in various phases of the view from Ganymede, if you assume an orbital system, okay? That's a bad assumption, it's a very bad assumption, but this is the artwork that Troy was producing, for that original book of ours. Okay, he's got a picture of Ganymede when it's between Jupiter and the sun. This is a hellscape, okay? And this is even worse. This is really, I mean, you would have to have your asbestos BVDs on. Are you with me? Greg?
Yes, I'm muted, listening. With you.
Yeah, I've got you, Ted.
Do you have a pair of asbestos BVDs? Probably not. Most people don't. Same thing, right? I'm telling you that nobody ever. This is a picture that then same thing. This is a scene that nobody ever saw. This would be. I mean, this is nobody's idea of a perfect human world, right? And Ganymede didn't look like this. Ganymede was a perfect human world. So let me just X out of this. What is it you're going to see if you're if you're living in Ganymede? You got two possibilities. Either you're living on the Jupiter sun facing side, on the northern side, in which case you're going to see a permanent eclipse with Jupiter in front of the sun, or you're looking back and you're seeing in the far distance at first, you're seeing, the Saturnian system, which would be very small at first in the sky. the logic of the diagram, right, this goes over. The entire system prior to the transfer event was, as usual for Herbig-Haro strings, a fairly straight line, right? Earth or Ganymede being off that center line or Earth approaching on a spiral path would prevent the transfer of aquatic mammals, including humans. Likewise, for whatever reason, the two largest rocky bodies in their respective systems had to be on the outermost positions of the systems for the transfer to take place. The transfer could not have taken place through one of the other Galilean moons. Okay? Likewise, having the sun between the two dwarf stars, which is the way Troy originally pictured it. See, Troy originally pictured the sun being in the middle of this whole thing. Well, I mean, you couldn't have a transfer of humans from Ganymede to Earth through the sun, right? That wouldn't work. Okay. The sun was either behind Saturn or behind Jupiter. Okay, but logic rules out the idea of the sun being behind Saturn. There's too many problems with that, right? It's like the oldest oral traditions describe the early period of Saturn being a dwarf star sun as a very dark sort of a purple dawn in which the middle part of the light spectrum is simply not present. Troy McLaughlin's diagram shows what that looked like, right? I mean, you've got like this, you've got this plasma sheath, right? The heliosphere of the dwarf star. You've got, this is not to scale or distances aren't right, but it's the basic idea. Saturn, Mars, Saturn, Neptune, Mars, Earth, right? And you're going to get light coming back from the heliosphere onto these planets from every which direction. You see what I'm saying? So that whereabouts you're standing on Earth wouldn't have mattered that much until you got into a late stage of the thing when you had auroral bands around the northern, the tropic, the temporal zones, right? You had ice ages. At any rate, you would expect the creatures of such a world to have huge dark world eyes. In fact, they pretty much all did, right? That included lemurs, tarsiers, leftover creatures, owls, right? They've still got these kinds of eyes, right? I mean, no normal animal has, modern animals don't have eyes like that. Neanderthal eye sockets, other hominid eye sockets, very much larger than ours. Accurate reproductions, such as those of Danny Ganymede, show the Neanderthal to be a fabulously bug-eyed creature. Here you've got the Neanderthal with the bug eyes, right?
So handsome.
Here we go. This is the good picture here. This is Ryan Darger's picture. In those days, Jupiter's largest moon, Ganymede, had a bright side facing Jupiter and the Sun and a dark side facing back towards the distant Saturnian system. The bright side must have looked something like this, right? This is what you're seeing. This, I believe, is the key picture to the whole thing, right? This is what life would have looked like on Ganymede when you are on the Sun, Jupiter's facing side of Ganymede, the front side. And you've got enough light to be warm, right? To be habitable, to be, you don't need heavy clothes or anything. You can go out and spend, a whole lot of time in the water. It shows these guys out looking for fish with their ladles. But Ganymede was shielded from the center mass of the Sun, right? The center mass of the Sun is blocked out by Jupiter. Isn't that a neat picture? Greg, what do you think of that?
Yeah, I like that. Yeah, that's a good picture.
This, I believe, is what you were looking at. You've got a permanent eclipse, right? This is not just one day. It's not just like for half an hour, once in a rare while, right? This is permanent. This is like, for a very long period of time. You looked at the sky and this is what you saw. The bright world, right? This says that the creature, humans and dolphins have relatively tiny eyes. You don't need the huge eyes for anything, right? You've got enough of the sun, you've got enough light, right? But it's like you're not going to fry, right? This is, well, what I believe. I mean, this answers the mail, right? This tells you like the solution to the problem, right? as the day of that first approach of the Saturnian system and the transfer of humans to Earth grew near, the view from the backside of Ganymede probably looked more like this. You've got ancient literature claims that Saturn lit up for a period, prior to the, well, I'm talking about the Holocene and the Greco-Roman Golden Age, right? This is not the Greco-Roman Golden Age. This is 50 or 60,000 years ago. This is a long time. Typically the thunderbolts, the people connected with thunderbolts are talking about the last 6, 8, 10, 12,000 years, right? I mean, the stuff I'm talking about is more like 50 or 60,000 or 100,000 years back. This, I believe, is what you would have been seeing. This would be the Eemian climate optimum, right, which I believe probably involved a deep prehistoric golden age. So I think you had a golden age before the golden age, right? At any rate, I think you would have seen the golden light behind the Earth, and then you would have seen the Earth. And I think that as the day of the transfer grew close, I believe this apparition, I think, would have taken up the whole sky or come close to it. In other words, the person standing on this backside of Ganymede, to see what's going on, right? You would have had people living on the backside, just like, man, you just got to, maybe they were worshiping all this stuff in the sky. Maybe, who knows, right? They didn't know what it was. They didn't know what to think of it. It's like, but then you ended up with a point where the thing got too close. You ended up with humans and dolphins and whatnot being transferred to the Earth and to the middle of the Pacific Ocean. That's what we were talking about, okay? The Eemian climate optimum, said to be warmer than the Holocene, coincides roughly with at least some estimates of the arrival of modern humans in Australia. Again, Ganymede hypothesis is compatible with the now of Australia theory of human origins. The Eemian optimum would most likely have produced a golden age similar to the classical Greco-Roman golden age of the Holocene, in which Saturn shed gold. I'm sorry about the pause in speaking. It's like I lost track of where I was on the video here. At any rate, Saturn shed golden light for a period of time, most likely measured in thousands of years. People on the back side of Ganymede thus would have seen a ring of golden light behind the blue of the Pacific side of the Earth, okay? The sub-Saturn point on Earth still being Pico Island, which is still the highest point of land in the Atlantic Ocean. Originally, the entire system, including both dwarf star systems, had been moving in the direction from the Saturnian system towards the Jupiter-Sun system. Apparently, Jupiter was never really far enough away from the Sun to prevent it being captured, and the capture itself slowed the combined Sun-Jupiter system enough for the Saturnian group to eventually catch up to it, okay? When that first near approach occurred, an electrical water bridge formed between Earth and Ganymede. Aquatic mammals, including humans, transferred to Earth. First, humans on Earth were culturally sophisticated, but not technologically sophisticated. Now, I think Troy has a problem with this. I think he would rather believe that these humans came to Earth, via space vehicles, right? But there's no evidence of that. It's like, they're direct descendants of the people of Australia, native Australians, and there's no evidence. These people did not have spaceships. High tech to them was an atlatl, and there's no way to think that they ever had spacecraft. After the transfer event, the Saturnian system recoiled and bounced back due to the electromagnetic repulsion. It did not bounce back on the same straight line on which it had approached, okay? As is the case with train wrecks, in which cars have no way to keep moving forward and move outwards, the entire Saturnian system was moved not only back, but off the center line of the entire system at a roughly 26-degree angle to it, okay? A period of time then ensued, which probably spanned a few tens of thousands of years prior to the final near approach and outright capture of the Saturnian system. By that time, Venus had come into existence and is shown off to one side of Jupiter. Okay, so here I've got like the Saturnian system's been knocked off the center line of the Herbig-Haro string, the original system. You've got Ganymede and the Galilean moons. Then you've got Venus sitting up here off one side of Jupiter, right? The second approach is on a spiral path because this whole system is probably turning on the axis. You understand what I'm saying, Greg? It's like having this whole thing turn would cause this group, which had broken off of the center line of the thing, to spiral, to move in a spiral, to move in a circle around, and at the same time move back again towards the Sun-Jupiter system, right, along with the Galilean moons.
You could see.
The second approach. I'm sorry?
You could see havoc was coming.
Oh, yeah. Second approach was on a spiral path through the offset. The large Saturnian bodies, Saturn, Neptune, flew around Jupiter, while Earth and Mars were caught up in the Jupiter-Venus alignment. Earth, Mars, Venus remained near the Sun, while the large bodies all ultimately threw themselves into the outer part of the system. Okay, that's the basic story, I believe. Since you had Saturn and Jupiter, you got tangled up together, right? You've got these wars between Zeus and Kronos that you read about in Greek mythology, and they both got like thrown out to the outer reaches of the system, whereas Earth and Mars and Venus remained close in. For whatever reason, they got picked up by the Sun itself, and you ended up with Earth and Mars and Venus on orbits which had dangerous points of intersection for a number of centuries after the flood, right after this final capture of the Saturnian system. And you have the kinds of catastrophes that Immanuel Velikovsky wrote about in Worlds in Collision, right? That's the basic gist of the story, okay? Ganymede hypothesis, few resources, right? Paperback, just get on Amazon.com, type in Ganymede hypothesis, right? Ganymede. You've got like a paperback and an ebook. Not overly expensive. The paperback's about $25, right?
Hey, Ted, I gotta tell you, that was the most excellent presentation. You really had it.
Okay.
You've come a long way.
It's not quite finished here. It's like Facebook. There's a Facebook group called Ganymede Hypothesis. On Amazon.com, right? Kindle ebooks, intro videos. There's a YouTube channel called Ganymede Hypothesis. All you have to do is get on YouTube, type in Ganymede, Ganymede hypothesis, and there it'll be, right? You've got introductions and you've got video intros like in about 6 or 8 languages. You've got on Facebook, you have a Facebook group called Ganymede Hypothesis. Any rate, I've got this one other Steemit page which I wanted to
go for.
Okay, deep prehistoric climate optimum, golden age, right? How much do you know about OpenAI, right? ChatGPT?
Nothing.
Have you? Okay, let me run this by. Okay.
I've seen a bit of work done. I've seen a bit of work done with it.
Okay, I've been playing around with this for the last.
Programmable. Yeah.
Okay, I've been playing around with this for the last year or so, and I would say that OpenAI, even in its present, even in the version that's been available for the last year and a half, whatever, 3.5. I mean, they're up to 4 now, right? They want you to pay $20 a month for that. 3.5 is free, and they may have a free version eventually of version 4. Okay. And then they've got like Q-Star, which is what the Elon Musk's lawsuit is about. Charles Ginenthal told me, is an excellent historian, told me that he was astounded at the state that you'd come to like 20 years ago when you first had Wikipedia available to people to do research, right? And, Charles Ginenthal grew up doing research the same old-fashioned hard way everybody else in my generation did, right? I mean, you go to libraries, walk around like an idiot from one library to the next, have your library order things, take 3 or 4 or 5 or 6 months, to ever get there. And you used to walk around with stacks of these stupid little 3x5 cards, right? Mark down information with a pencil or pen. At any rate, Charles Ginenthal told me that the difference that Wikipedia and these other new sources of information made was beyond belief. He said research tasks that used to take like weeks and months were taking like hours and days at the most, right? Now, I believe that OpenAI is as far above Wikipedia as Wikipedia was above the hard old-fashioned way, right? And now you've got this new generation of AI, which is, again, it's another step that big, starting from, what even OpenAI 4 can do is beyond belief, right? A typical user would have an easy time believing not only that OpenAI was the version which has been out there for the last year and a half was sentient. It seems to have its own mind, right? It's like you would have an easy time not only believing that the thing was sentient, but that it was borderline for omniscient, right? I've only ever managed to stump it once or twice, with normal kinds of questions. You cannot ask it questions involving controversial topics. You cannot ask it questions about the theory of evolution or about Immanuel Velikovsky or about any kind of thing like that, right? All you're going to get is garbage. You get artificial indoctrination. Nonetheless, I asked OpenAI, getting back to the present here, I asked OpenAI, like, what would have been the last previous climate optimum prior to the Holocene, okay? Without hesitation, it said the Eemian climate optimum, named after the river Eem in the Netherlands somewhere, okay? Aboriginal, okay. You've got some of the articles that you read about native Australians say that they've been there for 120,000 years. Some say 60,000, right? But it's like, the newer articles are coming in more like on the side of 120,000. Scientists discover Australians may be 120,000 years, well, none of them are 120,000 years old, right? They may have been there that long, okay? At any rate, OpenAI on the subject of climate optimums. Here's me, right? I say, okay, OpenAI, what would have been the most recent climate optimum prior to the Holocene? ChatGPT, right? OpenAI. The most recent climate optimum prior to the Holocene was the Eemian interglacial, also known as marine isotope stage 5e, right? The Eemian occurred approximately 130,000 years to 115,000 years ago. Well, I mean, that matches pretty close. You see, where do we just see a number like that? You see what I'm saying?
Yep, I'm following that, Teddy.
Yep.
Okay, I mean, that's not my imagination, and that's sort of an interesting coincidence, right? And that also answers the question that I've had as to how many of these new approaches there might have ever been between that first transfer and the more recent time period where you have the flood or the outright capture of the Saturnian system. How many of these new approaches might there have been? I figured logically I only need two, right? Logically, I only need that first approach where you have the transfer of humans from Ganymede to Earth, and then the approach when the entire Saturnian system was captured. Okay, now this says, but I didn't have any way of demonstrating. This says that like you've probably only got two. I was probably right? In other words, that you probably only have two. Like if you assume that these new approaches correlate to, climate optimums and climate optimums and what's the other term that I'm looking for? I hate getting old, and bright ages, right? And
I'm with you.
At any rate, you understand what I'm saying? It's like the literature of here's what the thinking is. The ancient literature is basically, even the Bible says that like the earth was dark, that you had like just a sort of a gloomy, dark place, right? Genesis is not talking about God creating the earth from nothing. It's talking about God recreating the living world of the earth after some kind of a series of enormous catastrophes. Sort of been before the flood, right? I mean, probably the catastrophe during which we lost the megafauna, right? So it's like you had golden age. The term that I'm looking for is golden age, right? So in other words, these new approaches probably correlate with golden age, with climate optimums and golden ages, right? So you've got this Greco-Roman golden age after the flood, or before the flood, I'm sorry, right? You've got this Greco-Roman golden age before, for a few thousand years before the flood, right, when Saturn lit up and ceased being just like a dark, like a deep purple dwarf star and lit up, right? And I believe that the same thing probably happened at the time of this Eemian global temperature, this Eemian climate optimum, right? This is still OpenAI speaking. During the Eemian, global temperatures were somewhat higher than those of the present interglacial Holocene, and sea levels were higher as well. The warm period is named after the Eem River in the Netherlands, where sedimentary deposits from this time were first studied. Okay, the Eemian interglacial was followed by a glacial period, and the Earth experienced subsequent glacial, interglacial cycles leading up to the present day, right? At any rate, the numbers are at least ballpark for the same. That's what I was getting around to. It's like you've got this Eemian climate optimum, right, which probably corresponds to the transfer of humans and other aquatic mammals from Ganymede to Earth, right? And then you've got this picture again of Ryan Darger's, this permanent eclipse, like the sun behind Jupiter. Couple of questions, right? What was making the backside of Ganymede bright enough for humans to want to be there at the time before the transfer? What was making Earth warm enough that those humans who splashed down into the Pacific Ocean didn't just die of exposure? It's probably this Eemian climate optimum and golden age, right? I mean, they probably, and that also says that these first humans that splashed down did not splash down into total darkness. If they had, they probably would not have survived. What I suspect must have been the case is that they splashed down into a world which was reasonably bright due to this climate optimum and deep prehistoric golden age, right? And then after a few more centuries or thousands of years, the Earth, the Saturnian system got dark again, went back to its normal thing of being dark, right? so that by the time it ever gets close to the Sun-Jupiter system again, it's like, you know, it lights up and the people see that as amazing, you know. Anyway, that's the picture that I have. Okay.
Yeah, keep going. Keep going.
I think that may have been pretty much the end of it. Okay, the Eemian had produced a golden age, possibly also lasting several thousand years. Seemed to answer both of our questions, right? The people on the backside of Ganymede were just seeing something like this for a few centuries prior to the transfer event, right? I mean, and then OpenAI describes Eemian as the most recent climate optimum prior to the Holocene, warmer than the Holocene, right? The hypsothermal here is, the hypothesis, I'm sorry, is that those first humans transferred from Ganymede splashed down in the Pacific in the middle of a deep prehistoric climate optimum and golden age, were then shepherded to the nearest point of dry land, most likely Australia or someplace else in the neighborhood of Australia, by whales and other aquatic mammals. That would be in keeping with the symbiotic relationships amongst aquatic mammals, including humans at the time, right? That's the end of this little page, you know, Steemit page here.
Oh, that was great. Yeah. Enjoyed it.
Right. So you've got some sort of an idea of this mental picture that I have, Greg. It's like, you know, this is, I believe, is like a 90% or 95% picture of the prehistory of our system, right?
Yeah.
There's some missing pieces, right? I mean, it's like I don't have all the answers, and you've also got a question that says that, like, okay, it's like we seem to have answered the questions like, where do the first humans within our little system here come from, right? We can answer that, but somewhere in the universe, there has to be a time and a place where you get the first humans ever to walk anywhere in the universe, right? And to know when and where that was, you'd have to have a direct line to God, right? I mean, I just don't have that. Right. I mean, you've got enough material. You're gonna have to cut, you know, do a little bit of cutting and pasting and whatnot, but
yeah,
you know, you've got enough material to make a video out of here.
You saved me the work. I don't have to do anything but maybe edit a few things, and that's it.
Yeah. Right.
Well, if you get something else going on, keep me informed. It's always good having you on. People love you, and we do too.
Okay, like I said, I mean, I want this to reach the widest possible audience, Greg. It's like whatever it takes.
I'll release it as an upload.
Right. You understand what I'm saying, right? It's like you need to, like anything, it's like you need to, you know, this is not perfect, but you need to clean this up just a little bit. But
no, it's good. I like it.
A couple of pauses where I lost the train of thought, or where
it's all right. We'll fix that.
You know, I lost myself on the video or on the Steemit page for
What'd you think?
Half a minute.
Andy,
I'm sorry?
Andy, what'd you think?
Andy, you still there?
Yeah, I'm still here, Teddy. I've been listening all the way through. Now,
is there anything that I'm leaving out here? Let me show you one other kind of a thing, Greg.
I think Andy wanted to ask you something.
Now, before you go any further, Teddy, so when you're talking Chat GPT, now I know people that are using it, and the difference between the free one, and the one that you pay $20 a month for, is it's like a totally different system. Got that much quicker, that much more information. And
yeah,
I know Ramon is even working on creating his own bots, running through it, right? So it is developing further, and apparently there's 4.5 or something on the horizon.
Yeah, look, it's like right now the difference is, Andy, right now the difference is between like version 3.5, which is what's been there for the last year or so, and version 4, which has just been announced within the last couple of weeks. Okay, now you've also got a number of similar products which compete with OpenAI, which are out there, which include
Yep.
like Claude,
Yep.
which
Yep,
include
that's
Claude, and which include a number of things. Right now, the other thing that you've got sitting out there, which they're not talking about just yet, is what they call Q-Star, and that's what the lawsuit is over. You see, it's like Elon Musk is suing OpenAI and Bill Gates and Sam Altman, claiming that OpenAI is in violation of its basic charters. The company was founded with money that was granted on conditions, right? And they said they're violating those conditions. I believe they are. Okay. Now the condition was, that OpenAI remain an open source company and that the benefits of their research flow openly to the human race. Now, and not be sold or conflated with Microsoft. Microsoft is like the largest corporation in the world. Okay, and it's like a $3 trillion corporation. Now, what you've got going on right now is that you've got Bill Gates and Sam Altman are out there trying to raise $7 trillion. That's trillion. That's not billion. That's not billion. That's $7 trillion to fund a global conglomerate producing kind of microchips, which they believe will be needed for the next generation of AI. Now, the problem, I think, is that I've spoken to my congressional representative about this. I believe you've got a problem. Like, is there such a thing as having a democratic government or any kind of responsible government when you have individuals inside a country, with their hands on $7 trillion? I don't believe there is.